All right, so the properties of matrix operations are basically the same as our regular operations. You see that we have the associative property will work. We see the commutative property also works. And then the distributive property of addition and subtraction, which means you can multiply the scalars into any matrix expression. With this said, we can go ahead and try to solve this matrix equation. So if we want to solve this matrix equation for x and y, we can quickly find it by using those operations. Now this is taken from number 34 on page 204 on inside the book. All right, let's start off doing this. We'll notice first that we can add the entries. The 3x can be added with the negative 4 for the first entry, first row, first column. Then if we go to the second row and second column, we have negative 2 plus 0. Well, that's just going to be negative 2. For the first row, third column right here, we're going to have negative 1 plus negative 7. Well, that's going to give us negative 8. And then the last one, we have 8 plus negative 8, and that gives us 0. Now notice that it's set equal to another matrix. And remember, corresponding entries in equivalent matrices are the same. So that means we could go ahead and solve this by noticing that 3x subtract 4 must be equal to this entry. And so we have 3x subtract 4 equals to negative 16. We notice that negative 2 does equal negative 2 and 0 does equal to 0. So that means that negative 8 must be equal to y. And that is true. Y is equal to negative 8. But we can still find x by solving that equation. We can add 4 to both sides. And so we have 3x is equal to negative 12. If we divide both sides by 3, we can quickly find our answer for x, that x is equal to negative 4. So there we have it. X equals negative 4 and y equals to negative 8. All right, let's go to the last thing that we have here. All right, so we're going to look at, in example 5, matrices in real life. Now this is taken from the textbook again in page 304. Now this one says baseball statistics. In exercises 37 and 38, we're going to use the following information about three Major League Baseball teams' wins and losses back in 1998, before and after the All-Star game. Now notice the information, the data that is given before. It says the Atlanta Braves had 59 wins and 29 losses. The Seattle Mariners had 37 wins and 51 losses. And the Chicago Cubs had 48 wins and 38 losses. Notice that after that it shows you how the wins are for after the game for the same teams. So what we're going to do for number 37 is use matrices to organize the information. So the way that we can do that is to set it up like this. Notice before we can set up our matrix so that the first column can represent the wins of each team, and then the second column can represent the losses. If you look at the side, each row, well, the first row can represent the Braves, the second row the Mariners, and the third row the Cubs. And you can see how matrices allows for us to put information and to organize it in a very neat fashion. Now, many of this type of concepts, we see this in data analysts and data scientists and computer scientists. They use these as they're using large amounts of data, and they could use what's also called arrays or matrices to do this. So now that we have our little matrix set up, let's actually start computing or putting in the information. Well, let's look at the Braves. The Braves have 59 wins and 29 losses. How about the Mariners? Well, the Mariners had 37 wins and 51 losses. And then lastly, the Chicago Cubs, well, they had 48 wins and 39 losses. And you can see right here, this information looks very neat. It's easier to see and comprehend than how it's written right now in the paragraph above. All right, so how about our after? Well, the after the All-Star game is still going to look the same. It has the same format. It's just that the wins and the losses change for each team. So if you look at the Braves, it says the Braves have 47 wins and 27 losses. So we can put them in there as row by column. And then the Seattle Mariners, they had 39 wins and 34 losses. And last of all, the Chicago Cubs had 42 wins and 34 losses. And so as we go further in the different sections, you'll see how we can analyze information like this. But for now, let's just go ahead, we finished number 37, and answer number 38. Number 38 says, using your matrices from exercise 37, Write a matrix that shows the total number of wins and losses for the three teams in 1998. Well, if you read that carefully, to find the total amount of wins and losses, well, we would have to add up the wins of the Braves and then the losses of the Braves, the wins of the Mariners and then the losses of the Mariners, and you get the picture. Now, we could do that very quickly with a matrix without losing our information or confusing the data. So if we set them up for our total, you notice that we can add the wins of the Braves with the wins before the Braves entered the All-Star game, and then after. So we see that there. We could do the same with losses and for each team. And we're simply using our understanding of adding matrices. We're adding the before matrix with the after matrix. And once we simplify that, we can quickly get our answers. We see that the Braves have won 106 times and lost 56 times in total. That the Mariners have won 76 times in total and lost 85 times in total. And then the Cubs won 90 times and then lost 73 in total. And this is how we can find that information. Now, the reality is we could put this into a computer or into any type of calculator or data crunching tool, and we can find information like this very, very fast.